Hello everyone, welcome back to the Dr. K. Makkoli Engineering Education channel. I am going to discuss today about the refrigerants and their desirable properties in this session. Then first we will take refrigerants, means what are the refrigerants and types of refrigerants. Then next, properties of good refrigerants. Whatever the desirable properties are there for the good refrigerants, we will discuss that one. And that the thermodynamic properties, physical and chemical properties we are going to discuss. Then refrigerants. First we will take the definition of refrigerant. A refrigerant is a working fluid used in the refrigeration and air conditioning systems, where in most cases they undergo a repeated phase transition from liquid to vapor and back again. Whatever the working fluid we are going to use in the refrigeration and air conditioning systems which undergoes the phase change, those are called as a refrigerants. Some common refrigerants are ammonia, used in vapor compression absorption refrigerators, carbon dioxide, used in marine refrigerators, sulfur dioxide, used in household refrigerators, methyl chloride, used in small scale refrigeration and domestic refrigerators, Freon 12, used in domestic vapor compression refrigerators, Freon 22, used in air conditioners. Here the Freon 12 and Freon 22 are most commonly used refrigerants in the refrigeration as well as the air conditioning systems. The next, desirable properties of good refrigerant. If the one fluid is to be treated as a good refrigerant, what are the desirable properties? And these properties are classified into two types. One is thermodynamic properties, second one is physical and chemical properties. First we will take the thermodynamic properties. A good refrigerant must have a low boiling point temperature at atmospheric pressure. At atmospheric pressure, it should boil at a lower temperature, that is a low boiling temperature. Next one, a good refrigerant must have a very low freezing point, because the refrigerant should not freeze at lower temperature. The refrigerant is working in the refrigeration system. There it undergoes the temperature change. Even though at a lower temperature also it should pass through, and at that temperature it should not freeze, so that its freezing point, whatever the temperature is there, it should be low. Next one, in order to avoid the leakage of atmospheric air and also enable the detection of the leakage of the refrigerant, both the evaporator and condenser pressure should be slightly above the atmospheric pressure. Here the two of the parts of the refrigeration system are the evaporator and condenser. In this, the pressure whatever are there, evaporator and condenser pressure, should be slightly above the atmospheric pressure, so that one thing we can avoid the leakage of the atmospheric air into the system, and another thing, easily we can detect any leakage of the refrigerant from the system. The next one, the latent heat of evaporation must be very high, so that a minimum amount of refrigerant will accomplish the desired result. In other words, it increases the refrigeration effect. Latent heat means is the amount of heat required to convert 1 kg of the refrigerant from liquid to convert 1 kg of the steam or vapor of that refrigerant. Okay, that amount required, if it is higher, then the smaller amount of refrigerant only receives the maximum amount of heat that can accomplish whatever the desired result required, and that is the refrigeration effect that we know will have the higher refrigeration effect. The specific volume of the refrigerant must be very low. Specific volume is volume per unit mass. For 1 kg of the mass, the volume should be lower one, so that the size of the lower specific volume of the refrigerant at the suction of the compressor reduces the size of compressor, so that we will have the smaller size compressor, so that the total refrigerant system will become say smaller and compact. Next we will go for the physical and chemical properties. A good refrigerant must have low specific heat when it is liquid state and high specific heat when it is vaporized. Specific heat means the amount of heat required to convert or to increase the temperature of the unit mass of the substance through 1 degree Celsius. When it is liquid state, low specific heat. That means the lower the heat is required for that one. When it is vaporized, the higher specific heat should be required. Then viscosity of the refrigerant at both liquid and vapor states must be very low, as it improves the heat transfer and reduces the pumping pressure. The viscosity means here the resistance offered by the flow of the fluid. Resistance offered by the one layer of the fluid to the another adjacent layer of the fluid is called viscosity. That is the resistance for the flow of the fluid. Okay, that it may be in the liquid phase or it may be in the vapor phase. The resistance should be lower so that it will reduces the pumping pressure as well as improves the heat transfer rate. A good refrigerant should be non-toxic. Means it should be non-toxic means non-poisonous it is. A good refrigerant should be non-corrosive to prevent the corrosion of the metallic parts of the refrigerators. Okay, it should be non-corrosive so that it should not corrode the what are the parts where it is flowing. Chemically stable. An ideal refrigerant must not decompose under operating conditions. That means that there are various temperature changes taking place in the refrigeration system. In those changes, it should not decompose and chemical reaction should not take place. The chemically it should stable. The coefficient of performance COP of a refrigerant must be high so that the energy spent in refrigeration will be less. If the coefficient of performance is higher, the efficiency of the refrigeration should be higher so that whatever the energy required for the operation of the refrigeration system will be less. A good refrigerant must be odorless, otherwise some foodstuffs such as meat, butter, etc. lose their taste. The refrigerant should be odorless. It should not have any odor or a smell. Otherwise, the foodstuff or perishables what we keep inside the refrigerant, it will get their odor. Okay, that will cause some taste change. A good refrigerant should have any leakage, should not have any leakage, should have any leakage can be detected by a simple test. Okay, if any leakage of the refrigerant is there, that should be easily detected. A good refrigerant must not react with lubricating oil used in the lubricating the parts of the compressor. Where the moving parts are there the lubrication is required. Therefore, in the compressor, the lubrication is used. That lubrication, whatever the oil is there, with that one, the refrigerant should not react. Okay, these are some of the properties, desirable properties, which are to be associated with the refrigerant so that it can be used as a refrigerant in the refrigeration system. This about the refrigerants, and thanks for watching this one, and you can continue watching the next way. I am going to explain, that is vapor compression refrigeration system and vapor absorption refrigeration system, how these refrigerants are using there and how the properties are effects there, that I am going to explain. Thank you for